Okay, good evening, everyone. Welcome to Physics, O-level Physics lesson. We'll continue with our second lesson on DC circuits. We'll be doing questions today. My name is Mr. Chu. Today is the 24th of May, 2022. Okay, so let's begin. Okay, we'd like all of you to do this question and type out the answer in the chat. Okay, sorry, not sorry. Do question number 31. Okay, you may begin. Do question number 31. Okay, Qiao Xing, well done. Yi Ting, well done. Ryan, try again. Okay, Kwan, try again. Okay, Wei Kwan, well done. Do you know why? Ryan, incorrect. Try again. Oscar, incorrect. Okay, seems like many of you are not getting this correct. Okay, if I were to redraw this, you see whether does it help? Okay, if I were to redraw this, you see whether does it help? Okay, if I draw it like this, do you think it will help now? Okay, so your D is here, your C is here, your B is here. Okay, the A is not there, but never mind, we put the A here. Okay, so if the current from the battery is 1.5 ampere, okay, the way I redraw is not very good. Okay, not very good. So let me just clear the whole thing. Okay, but what I'm trying to tell you is that if I were to redraw like this, for example, if a current coming in is 1.5 ampere and the current going out is 1.5 ampere, and these three branches are identical. Okay, these three branches are identical, have the same resistance. Okay, the same resistance. At this point where the current comes in and split into three ways, okay, are you all convinced that each way is 0.5 ampere? Are you clear about this? If a 1.5 ampere current comes in and then reach this point, and because the three branches have the same resistance, okay, this 1.5 ampere would actually split into 0.5, 0.5, 0.5. So now if I were to draw over here, this is 1.5 ampere. So every branch will be 0.5 ampere. Are you clear about that? Okay, so D and C will be wrong. So which one of these answer will be correct? A or B? Are you clear about this now? When I explain like this, is it helpful? If you think it's helpful, give me a yes reaction. If I make you more confused, give me a no reaction. Oscar, you are confused and become enlightened. Okay, are you clear about this? Okay, why I redraw the thing? Because what I draw just now is not the same as this. Okay, but what you all need to know is the three branches here. Ignore the ammeter, it's just confusing. The three branches will have 0.5 ampere because the load of each branch are the same. So this 1.5 ampere of current will be split equally among the three branches. So each branch will be 0.5 ampere. Okay, so in this case, B is 0.5 ampere. A is a combination of B and C. So the only answer for this will be A. This will be 1.0 ampere. Is that clear? Okay, then do you all know why my initial drawing is not correct? Because the A, the ammeter A is not where it is. It's not here. Okay, the A is not here. Okay, I actually shift this point all the way to the center. Okay, so therefore it's a bit not very clear. So my drawing just now doesn't reflect the correct position for ammeter, but the idea is each branch has the same resistance, the same load. So the current on the three branches should be the same. Okay, so for the current on the three branches to be the same, this 1.5 ampere need to be split equally among the three. Okay, for this question, just split equally. When you go to higher level, you need to calculate here and there. Because different resistor will give you different kind of value. But the idea is this 1.5 ampere split equally among the three branches because they have the same load. Is that clear? Can? Okay, I hope this will clarify about the circuit to you all for a start. Okay, let's look at the next question. Okay, do question number 32. Okay, you all may begin. Okay, do question 32. Okay, so for the questions that we're going to do it for the next few weeks, there will be quite a lot because it's combined this topic as well as the last topic. The last topic is just introduction to the concept of current, potential difference, and resistance. Okay, this topic talk about some application, and then when you combine together, there'll be a lot of questions. Okay, so start doing question number 32. Okay, question 32, no answers yet. Okay, Yiting, well done, well done. Hooray, well done. Ryan, very good. Okay, how about the other three? Qiao Xing, well done, well done. Last two students. Bei Kuan, incorrect. Okay, the ammeter reading here is 3 ampere. Okay, 3 ampere. Okay, Bei Kuan, correct now. Very good. Oscar, incorrect. Incorrect. I'm tempted not to explain this question. But just let me explain. Hopefully you all of you will get it. Okay, so for example, you can do the manual method. Okay, but let me explain the concept to you. Okay, when the battery provide an EMF of 6 volt, because these two resistors are in parallel to each other, the PD of these two resistors are also both 6 volt. Okay, do you know why? Because before the point is 0 volt. So anywhere along this point here is all 0 volt. Is that clear? Any point along this point is all 0 volt. Likewise, the battery increase the potential to 6 volt. So on this point is 6 volt. So if I measure the difference between these 2 points, if I put a voltmeter here, it will show 6 volt because the difference between these 2 points is 6 volt. So along this line, they are all also 6 volt. 6 volt, there's no load there. It doesn't increase or decrease. There's nothing in between except for the wire. So on the left side is all 6 volt. So the potential difference between both resistors are both 6 volt as well. Clear so far? Okay, next. We know that the first resistor is 2 ohm. The second resistor is 2000 ohm. Okay, just by using the manual method, okay, the manual method, you know that I is equal to V equal Ri. V equal Ri. So V over R, correct? So current is equal to voltage divided by resistor. Okay, so based on calculation, you know that this value is 3 ampere. And that is why originally the value here is 3 ampere. Okay, likewise, on the bottom, to find the current, we also use V over R. So V divided by R, you can see this is a very small value. Okay, it's a very small value, 6 over 2000. Okay, ampere. Okay, and because they are all parallel, even though there's one more branch, the original branch will still be 3 ampere. The original branch will still be 3 ampere because hello. Okay, sorry. The the thing just disappeared. The book just hang. I thought my Zoom hang, okay, but it's not. Okay, hold on for a while. Hold on for a while. Okay, Ryan, and Ryan, your camera is not on. Okay, let me pause for a while, Connie. Okay, so because the PD across these 2 ohm is also 6 volt, so the current will always remain as 3 ampere, regardless how many things we add in parallel. Are you all clear about this? Regardless how many we add, this branch, okay, having a PD of 6 volt will always give a current of 3 ampere, regardless of how many branches you have. Okay, so in this case, there's one more branch. Okay, one more branch where the resistance is 2000. Okay, the PD is hold on. Why is it like this? Okay, this is 2000. Okay, wait. 2000 ohm. So the current here is very, very small. It's 6 over 2000 ampere. Okay, so regardless how many branches we have, the first branch will still be 3 ampere. The second branch, the current will depend on the load. Okay, the PD will still be 6, but if the load has a high resistance, the current will be small. Okay, so this ammeter will measure the combined current of all the branches. Okay, so since the first branch is 3 ampere, the next branch is a small current, and therefore the answer here is D. Okay, are you clear about the concept? It's a concept. It's about a concept. It's not about calculation. Yeah, I'm just using a calculation to explain the concept. Is that clear? Okay, so even if we have extra branches, the original current will still be the same 3 ampere if your PD remains at 6. Okay, this current will not change. Just that we add more branches, there'll be more current, more current, more current. So this ammeter here will measure a combined current of all your branches. Clear so far? If you understand my explanation, give me a thumbs up. Thank you, Bei Kwan, Chelsea, Ryan, and Yuting. Oscar and Howry, are you okay? Okay, then let's move on to the next question. Do question number 33. Okay, 33, you all may begin. Yuting, well done. Okay, Yuting so far the only person for answer. The rest of you. Howry, well done. If you all need help, let me show you. Let me just redraw, then you'll see whether you understand. Okay, so P is here. This is P. This is when X is at P. Okay, next. This is when X is at Q. All right, so both of these are 10 ohm. So how does these two resistors divide the 6 volt? Okay, how does these two resistors divide the 6 volt? So if I put this line below, it will be 0 volt. If I put this line on top, this P will be, okay, this P will be 6 volt. Below here is still 0 volt. Okay, so the answer will be moving from 3 volt to what? Clear so far? Howry, well done. Bei Kwan, correct. Hey, wait, hold on. Did I do something wrong? Okay, sorry, I did something wrong. My drawing is wrong. Okay, ignore this. Here is where the Y is. Okay, here is where the Y is. Okay, ignore this. Okay, how we correct? Xiao Xing, your first answer correct, they become wrong. Bei Kuan incorrect, yeah? Oscar incorrect. Okay, so at first it was 6 volt when your X is at the top, okay, at the P. Okay, it's 6 volt because it's right on top. Clear so far? So this X is at 6. But the Y is right in the middle. This Y will be 3 volt. Clear? Then if you were to put a voltmeter in between, the voltmeter measure the difference between these 2 points. At first, the voltage will be 3. Okay, so answer will be 3 volt. Then your Y here is still at 3 volt, but your X has moved from P to Q, which is all the way below here. Okay, so your Q here is also 3 volt. Thus, if I were to put a voltmeter in between, this voltmeter will show 0 volt. Is that clear? Okay, and therefore the answer for this is B. Okay, Bei Kuan, Oscar, and Ryan. Do you understand my explanation? Okay, so sorry, at first I see wrongly. The Y is at the middle, not at the bottom. Okay, the Y is at the middle, not at the bottom. So the X actually moved from the top all the way down. So at first it's on top, you give a 6 volt reading. So the difference between these 2 points is 3 volt. Then when you move down, your Y will give the reading of 3 volt. So difference between these 2 points is now 0 volt. So the potential difference changed from 3 to 0. Okay, if you understand me, give me a clap reaction. Okay, thank you, thank you. All right, all understand. Let's do the next question. Okay, do number 34. Okay, you all may begin. Okay, do number 34. Okay, you all may begin. Okay, you all remember what is thermistor? The greater the temperature, the smaller the resistance, the higher the current. So what would this be? Okay, Yu-Ting, correct. Okay, quickly give me the answer. I go take a sip of water. Ryan, well done. Oscar, incorrect. So let me repeat again. As temperature goes up, resistance will go down. Okay, Howry, well done. Oscar, well done. How about the rest of you? Bei Kuan and Xiao Xing, what is your answer? Okay, Chelsea incorrect. Bei Huang, well done. Okay, so in this case, as the temperature goes up, resistance goes down. When the resistance go down, where the V remains the same. V remains the same. So I is equal to V over R. When the resistance go down, what happened to your current? Current will go up. Okay, so when the temperature goes up, your resistor will come down, and your resistance will come down, and your current will go up. Okay, so your graph should be going upwards. Clear so far? Okay, be going upwards. So in this case, going upwards, it will be either A or B. Okay, it will be either A or B. Okay, however, why the answer is not B is because your resistance will not become constant. Okay, you just go up higher and higher. So, no, sorry, I'm sorry. Your resistance will not become constant, your current will not become constant. Okay, so your answer would be A. Okay, so C and D is definitely wrong. I repeat again, as temperatures goes up, resistance comes down, current will go up. Okay, and so your answer should be an upward graph. So it's either A or B. But why is it not B? Is because the resistance will not reach a point where it becomes constant like this. When it becomes constant, the current becomes constant. So that is not what happened. So therefore, the answer is A. Okay, Chelsea, you understand now? Give me a reaction if you understand my explanation. All right, let's do the next question. Okay, all of you now do question number 31. Okay, do 31. You all may begin. Okay, for this question, you have not learned the formula yet. Let me give you the formula. Power is equal to VI. Okay, the second step, you need to know this formula. Okay, some of you in school may have learned already, but I haven't shared with you all before. So this is the formula that you need to know. Okay, Oscar, well done. Xiaoxing, well done. Yuting, well done. Okay, so first of all, can you find the current? Current is Q over T. Okay, so first you find the current. Okay, you will get 2 ampere. You know this is 2. You know the power is 24. Can you find the V? Okay, that's all. That's how you do this question. Okay, first you need to know how to find the current, which is 2 ampere. Then you need to find the potential difference using this formula, P equal to V over I. Is there any other way to do? There is no work done down here, right? Yeah, that's the only way to do. Okay, so if you are clear about this, give me a yes reaction. If you are clear about this, give me a yes reaction. Okay, meanwhile, can all of you do question number, let me see, 32. Okay, 32, I think you did before, but let's revise. All of you now do question number 32. Okay, do the question number 32, 32. Okay, Yiting correct, Oscar correct, Ryan correct. So for 32, what is the formula you need? Okay, for question 32, the formula you need is V is equal to work done over charge. Okay, work done over charge. So you just need to fill in. In this case, the potential difference is 12. The charge is 100. Can you find the W? Okay, Xiaoxing incorrect. Yeah? Okay, so for question 32, it's just testing your understanding of the formula of potential difference. So V equal to W over Q. Okay, so for Xiaoxing, are you able to get the answer now? Xiaoxing, okay? What is the correct answer now? Okay, well done. Well done. How about the rest of you? So the answer for question 32, okay, would be D. Okay, your W here will be 1200. Is that clear? Okay, for question 31, the answer is B. Okay, so let me continue the next question. Let's clear all this. Let's do question number 34. Okay, 33, we'll skip. I think we did before. Let's do 34. You all may begin. Okay, this thing is called the diode. Do you know what's the diode? Okay, a diode only allows the current to move in one direction. Okay, this question also quite weird. It also shows you AC current supply. Okay, AC supply. So if I were to draw a current over time, AC supply is like this. So you'll be moving in one direction, go up, come down to 0. Then your current will move in the opposite direction, then it becomes 0. Then it change direction again. And then it does this 50 to 60 times a second. Okay, so this is called AC current. Okay, so when we have a diode, okay, what happens is you only allow the current to move in one direction. So if there is an AC current, okay, so if there's a diode, inside the circuit, what happens is you will see something like this. Those at the bottom, no current will flow through. Okay, because you only allow the current to move in one direction. Okay, so when you put a diode in the circuit, only one direction there will be current. The other direction will be all cancelled out, will become zero. Clear so far? Okay, so this is what happens when there is a diode. Okay, I see some answer. Bei Huan correct. Oscar Yu Tian incorrect. Okay, let me share with you another thing. This thing here is the car battery. Okay, this is the car battery. So when you have a car battery like this is your engine, your current move this way, correct? Okay, if you have a car battery like this, where the plus is on top, the minus is below, the car battery provides the current in one direction, it will move this way and supply the current to the motor to run. Okay, the question now is, you need the current to move in the opposite direction to charge the battery. Okay, so you need the current to flow, okay, to flow which way? You need the current, let me show you. In this case, you need the current to flow this way for it to charge the battery, opposite direction. Clear? Okay, so you need your current to flow in the opposite direction to charge the car battery. So you're using the AC supply to charge the car battery. And the car battery will only be charged if the current is flowing in the opposite direction, as mentioned in the question here. The current in the opposite direction will recharge the battery. So which of these circuit allows the AC supply to supply a current that move in the direction of the red arrow? Is that clear now? Okay, how Ray, well done, Yu Ting, well done, Oscar, well done. So are you clear about this now? And then a diode like this, the triangle is where it allows the direction of current to flow through. So this means that okay, this, for example, this diode here means that you allow the current to move this way. This diode here allows the current to move this way. This diode here allows the current to move this way. And this diode allows the current to move this way. So which of these four diagrams allow the current to flow in the direction of this red arrow so that it will recharge the battery? Okay, Oscar, well done. So are you all clear about this now? So only A allows the current to move from left to right and then down towards the car battery to recharge it. For B, this diode allows it makes the AC current move from right to left, so it will not work. Then for C, your AC supply, when you reach this point, okay, but moving forward, it will still be AC. Okay, in the middle, the current move down, but moving to the right is still AC. So it does not recharge because it use and recharge. It does not charge the battery because on this side, okay, this side is still AC. Hey, why my pen like that? Okay, on this side is still AC. Is that clear? Okay, if you are clear about this, give me a clap. If you are clear about this question, give me a clap. Is it helpful? Oscar, how are you? Okay? Okay, let's go on. Okay, all of you now, let's do question number 30. Okay, how does a diode look like? Which of these shows a diode? Okay, you all may begin. Okay, this one is either you know or don't know. So quickly give me the answer. Which of these shows the current voltage relationship of a diode? Remember, diode only allow current to move in one direction. Okay, so Yiting correct, Xiaoxing correct. How about the rest of you? Ryan incorrect, Ryan. Which of these graph shows that there is a current only in one direction and not in the other? Okay, Ryan, well done. How Ray, well done. Oscar, what's your answer? Okay, Oscar, incorrect. So which one has current in one direction and no current in the other direction? Okay, Oscar, what's your answer? Okay, sorry, Oscar, you changed your answer, correct. Okay, so are you all clear about this? Okay, the next question, let me continue. Okay, do question number 31. Okay, you all may begin. Okay, I think this is an easy question. Yiting, correct. Xiaoxing, correct. Hao Rui, correct. Oscar, well done. Anyway, the previous question, the answer is, later I'll show you. Okay, Oscar, well done. Okay, for this question, the answer is C. Okay, when the switch is closed, because there's a resistor here and the switch is closed, most of the current, okay, will flow this way. Okay, most of the current will flow this way. So when most of the current flow this way, this V will drop. This VI will increase because this will be this V is actually equal to V1 plus V2. Okay, so when V2 drop and then this V remain the same, your V1 will have to increase. Clear so far? All right, okay, let's do the next question. Okay, do question number 33. You all may begin. You think you have a question for me? Why is V kept the same? You mean the previous question? Okay. Let me just draw it here. Okay. The EMF of the previous question, let's say this is 100 volt, for example. Okay, this battery will always supply 100 volt of EMF. Clear so far? So in your circuit itself, on the right side is always 100 volt. On the left side is always 0 volt. Clear? So when you close the circuit, okay, all the current will skip. All the current will skip this resistor here. So therefore, this voltmeter will now go down to 0 volt. Can? But because from the left to the right is still 100 volt, so from left to right, based on your load, it will still be the same as 100 volt. Understand, you think? Or you're still confused? Okay, you think you understand what I mean? Give me some response. You clear so far? Okay, good. So now everybody, question 33. Let me see what's the answer for 33. Okay, I see a lot of answers. Okay, Ryan, correct. Oscar, try again. Xiaoxing, correct. Bei Kuan, try again. Yuting, try again. Hao Rui, well done. Bei Kuan, try again. Okay, V is equal to Ri. Okay, so you all know that down here, if I were to put a voltmeter, the value here would be 5 volt. Correct? 5 times 1 is 5. 2 times 2.5 also 5. Okay, so this branch will actually have a potential difference of 5 volt. Then, what is the total current here? So this current is split into these two. So this total current here will be 7 ampere. Clear? So same thing, if I were to put a voltmeter here, V equal to Ri. So this voltmeter will show a potential difference of 7 volt. Clear? So this V, the EMF provided by the battery will be a sum of the PD of these two values. So what's the answer? The answer will be C. Are you clear about this now? Okay, for this question, if you understand, give me a thumbs up. Thumbs up. Okay, let's do the next question. Earlier on, we do a thermistor. So now we're going to use the light dependent resistor. Okay, let's do question number 34. A light dependent resistor. Just like a thermistor, when there is more light, resistance will drop. So current will increase. Clear? So do question 34 now. You all may begin. Ryan, you're so fast. Okay, Ryan, your answer is correct. Well done. Okay, Bei Kuan, well done. Yuting, well done. How about the other three of you? Oscar, incorrect. Okay, Oscar, well done. Okay, so when a bright light shown, resistance goes down, currents go up. Is that clear? current will definitely goes up. So your current actually will goes up. So answer will be increase. And because the resistance of this goes down, this remains the same. The percentage of these resistors over the whole thing will also increase. So this V will go up as well. Clear so far? Are you clear about this? So answer for this will be D. Okay, so for question 34, okay, answer is D. Okay, sorry, I did the wrong thing. sorry. But it's still the same. Okay, so in this case, the answer is D. Chelsea, do you know why now? Or you still need me to explain one more time? Chelsea, do you need me to explain again? Or you're okay with this question? Your no means what? It means you don't understand or you don't need me to explain. Okay, good. Let's continue. Next question. Thank you, Chelsea. 2016. Let's do question number 31. Okay, all of you do question 31 now. Okay, let's not 31. Let's do question 32. Okay, do question 32. You all may begin. Okay, I see a few answers, but I'm confused which answer you are from where. Okay, Yuting, well done. Oscar, you changed your answer, so incorrect. Xiao Xing, well done. Ryan, incorrect. Okay, from all the answer here, we are convinced that I1 is the biggest. Okay, so I1 is the biggest. A definitely is wrong. Okay, none of you all choose A. Okay, so now the question is, which is bigger? Okay, so I1, okay, from here, we know that I1 is equal to I2 plus I3. Okay, so the next question is, which has a higher current, I2 or I3? Okay, so for example, if this is 1 ohm, this is 1 ohm, this is 1 ohm, because they're identical, just using simple as illustration. So the branch in the middle has a 1 ohm bulb. The branch below has a 2 ohm resistance. So which one will have more current? The one that has more current will be the one that has less resistance. Clear so far? Okay, so this is less resistance. The current will be more here. Okay, so therefore I1 will be more than I2, is more than I3. Okay, answer will be D. Okay, Pei Kwan and Ryan, do you know a mistake here? Oscar, do you understand now? Okay, so the answer for this is D. Okay, because I2, the current I2 goes through a lower resistance compared to I3, which has a higher resistance. So I2 will have more current compared to I3. Is that clear? Okay, if you understand this, give me a thumbs up. For this question, half of you did not do well. Okay, all okay? Okay, let's do question 33. Okay, you all may begin question 33. Okay, start now. Start now. Yiting, give me the answer for the A3. Why you're so fast one? Or is that the answer for your previous one? Okay, for this one, Yiting and Ryan, you got it correct. Well done. Hooray, well done. Oscar, well done. This will give you a combined resistance of 12. How about the rest of you? Okay, this will give you a resistance of 4/3 ohm. Okay, I will give you a 2 wrong answer already. Okay, Pei Kwan, well done. Qiao Xing, well done. Okay, so all of you know, this one will give you a resistance of 2 ohm. Okay, so 2 plus 4 will give you 6 ohm. And therefore the answer is D. Is that clear? Clear? Okay, let's do the next question. Let's move on. Okay, let's do question 35. You may begin. Question 35. Okay, same thing for this. If the light go up or the temperature go up, both will give you a lower resistance that result in a higher current. Clear? Yiting incorrect. Oscar incorrect. Pei Kwan incorrect. Pei Kwan still incorrect. Okay, you want the thermistor to have the greatest PD. Okay, so if I want this V, it should be high. If I want this V, it should be low. Okay, so let me draw another example. If I want this to be high, okay, does it mean that my resistance here should be as high as possible and my resistance here should be as low as possible? Does it make sense? Okay, using the potential divider, theory. If I want this this PD to be the highest, my resistance should be very, very high. Right? This resistance should be very, very low. I'll give it as an example. If this is a 10-volt battery, okay? If this is 5 ohm and 5 ohm, this will give you 5 volt. Is that clear? However, if this is 8 ohm, okay, if this is 8 ohm and this is 2 ohm, this will give you 8 volt. Are you clear about this? Okay, so if I want this voltage or this potential difference to be as high as possible, this resistance should be as high as possible, or this resistance should be as low as possible. So which scenario will give you a high resistance for the thermistor and a low resistance for the light dependent resistor? So far, none of you got it correct. Okay, all of you try again. All give me answer again. For this potential difference of this thermistor to be the highest, my resistance for this should be the highest. Do you agree? My resistance for this should be the highest. And then my resistance for this should be the lowest. So when the resistance for this lowest, is it bright or dark? When the resistance for this is highest, is it hot or cold? Okay, Pei Guan, correct now. Yiting, correct now. Xiao Xing still incorrect. Huh? Ryan still incorrect. Huh? Okay, so if I want this V to be very high, this resistance should be very high. So for my thermistor to have a high resistance, my temperature should be low, correct? So my temperature should be low so that my resistance is high. So my environment should be cold. Clear? Likewise, if I want my light dependent resistor to have a low resistance, if I must have a lot of light. Okay, to have a lot of light, it should be bright. Are you all clear? You understand now? Okay, if you understand this question, which I think a lot of you could struggle, if you understand perfectly, give me a thumbs up. If you want me to explain again, can give me a yes reaction. Okay, if you understand perfectly, give me a thumbs up. Ken, Oscar, and Harry, are you okay? All right, let's move on. Okay, let's do question 30. Okay, you all may begin. Okay. Xiao Xing try again. Yiting correct. Oscar try again. Okay, Xiao Xing, well done. Bei Huan, Oscar try again. Okay. Okay, let's do this question together. Okay, welcome back, Ryan. Okay, first of all, if I were to add one more resistor here, this whole thing, have you all learned before? The resistance will drop. Is that clear? This resistance remains the same. Okay, because this drop, this remains the same, the combined resistance will also drop. So the resistance of circuit decreases. Is that clear? Then, same thing as the potential divider. If this is a 10 volt thing, and originally is 5 ohm and 5 ohm, so this originally 5 volt and 5 volt. If this value goes down, okay, if this value goes down, what happens is this value will goes down and this value will go up so that the total PD will be 10. Is that clear? Okay, when this value, this resistance goes down, your potential difference will also go down, right? But because the total potential difference is still 10, for your lamp, your PD will go up. Okay, therefore, your PD across the lamp will increase. So answer is C. Okay, do you all get this idea now? Do you get it? Or you're still confused? If you get it, give me a yes reaction. If you're still confused, give me a no reaction. After doing similar question for a while, I hope you understand now. Yes, it may take some time to understand at first. But if you understand potential divider, If you understand that the resistor in parallel will reduce the resistance, okay, then you should be okay. Come. Ryan and Howrey, are you clear now? All right, let's continue. Let's do question number 32. Okay, do 32 now, everyone. You all may begin. Okay, Howrey, well done. Ryan, well done. Yuting, well done. How about the rest of you? This one is what we mentioned last week, right? What is the resistance of the voltmeter? Xiao Xing, what's your answer? Correct, well done. Oscar, how about you? Left with Oscar and Pei Kwan, what's your answer? Well done, Oscar. Well done, Pei Kwan. Okay, so all of you know voltmeter. Okay, a voltmeter shouldn't allow any current to flow in. It's just measuring the difference between the 2 points. So the resistance of a voltmeter must be very high. Okay? And a voltmeter must be in parallel with the what do you call this? Okay, with the load, which is the resistor. Okay, so it must be parallel with the resistor. So answer would be A. Okay, well done. Okay, let's do 2 last question or 3 last question. Okay, our view. Hold on. Do question number 35. You all may begin. Okay, do question 35. Okay, start. Okay, Yi Ting, well done. Bei Guan, try again. Try again. Xiao Xing, well done. Okay, can you see down here? These two should be the same, right? Because there's no other way the current can go. So I1 must be the same as I2. Are you all convinced? Because there's no other separate route to go. Okay, once the current move here, it will come here. So there's no separate route to go. So I1 must be equal to I2. So answer will be 4 ampere. So the question now is, what is the PD of V2? This question is not hard. Okay. The EMF is 12 volt. So these two, V1 must be equal to V2 plus V3. Is that correct or not? Okay, V1 must be equal to V2 plus V3. Okay, so what's the answer? Bei Kwan, try again. Oscar, try again. And the rest of you, what is the answer? Can you all tell me? Bei Kwan, try again. Howard, well done. Okay, so V1 is 12 volt. V3 is 4 volt. What is V2? Oscar, what is V2? Okay, got it. Well done. Bei Kwan, well done. Okay, so V2 is 8 volt. So therefore, the answer for this is D. Is that clear? Okay, let's do the next question. Two last question. Bear with me. Two last question, and then we'll be done for today. Okay, do question number 32. This one. Okay, you all may begin. You all may begin. Hey, nobody got answer. Are you all stuck here? Bei Kwan, try again. Yiting, try again. Yiting, try again. Okay. This is 4 volt. This is, this is 4 ampere, this is 2 ampere. So the current moving through here will also be 2 ampere. This is 12 volt and this is 2 ampere. What will be the resistance here? Resistance is equal to V over I. Okay, so the resistance here is 6 ohm. Clear so far? Clear so far? Okay, so for this, V is, okay, same formula, V equal RI. Okay, so what is the voltage over here? Okay, V is equal to RI. The resistance is 3, the I is 2, so the voltage is 6. Total is 12. So what is the V here? V here will also be 6. Clear? So you know V is 6, the current is 2. Your resistor for this is V over I, which is 6 over 2, and therefore the answer is 3. Okay, so the answer for this would be C. Clear so far? Oscar, Pei Kwan, understand? Okay, both Oscar and Pei Kwan, do you understand now? Yiting and Hao Rui, do you understand now? Okay, last question, very last question for today. Let's do question 33. If you get it correct, I call your name, you may leave. Okay, you cannot do it correctly, then you stay until you can do finish. Okay, you all may begin. Let's do this question now. You all may begin. Hey, how rate just disappear? Never give the answer yet. Pei Kwan incorrect. Try again. Okay, so I can write down here 6 kilo ohm become 2 kilo ohm. Okay, 6 kilo ohm become 2 kilo ohm. So my first question you must think of is, does the PD here increase or decrease? Okay, at first is 6 kilo ohm, it dropped to 2 kilo ohm. So 6 and 2, the PD here should be high or low compared to 2 and 2. So the PD should increase or decrease. Okay, when it's 2 and 6, it is 1/4. The PD is 1/4 of this value here. When it is 2 and 2, it becomes half of this value here. So it becomes 1/4 of this value, become 1/2 of this value. So at first, okay, let this be V. Okay, this value here, let this be V as well. Okay, I change this to E. Okay, so V value at first is half of E. Okay, sorry. Wrong, wrong, wrong. Okay, so the value of V first is used to be 2/8 of E, then become 2/4 of E. Is that clear? So therefore, from here, you know that at first, the V here is 1.8. So can you find what's the value of E? Okay, if at first the V is 1.8, and this 1.8 is 2 out of 8 of the E. So can you find the value of E? So 1.8 times 4 will be? Okay, so the value of E will be 7.2 volt. Okay, so this value of E is still 7.2. Okay, but the V now is now 2 out of 4 because it reduced to 2 kilo ohm. So what is the new value of this 2 now? Okay, so once I call your name, you may leave. Okay, Xiaoxing, well done. Oscar, well done. Bei Kwan, well done. Sorry, Bei Kwan, not well done. You from correct become wrong. Okay, Yiting, you may go. Oscar, you may go. Xiaoxing, you may go. Bei Kwan, you may go. So left with only Ryan. Ryan, what's your answer? Ryan, try again. I will give you the answer. E is 7.2. E, this one. So 2/4 of 7.2, what's the answer? Ryan, calculate again. Okay, well done, Ryan. You may leave. Okay, so the answer will be C. Okay, thank you, everyone. See you all again next week. Any question for me, Ryan, Bei Guan? If not, both of you can go. Okay, thank you and goodbye.